Bismillahirrahmanirrahim. Yes, hello everyone. Assalamu alaikum. How's it going? So today we'll try to solve the problems at Chapter 2 in Chapter 2 for the course CHENG465 Chemical Process Safety, and it is going to be very interesting, by the way, because you're going to see the beauty of the equations, or from the tables that we have. And from the different definitions we were talking about, probits and percentage of people affected. I think so it's a good opportunity now to see how we are going to use those problems. Okay, so going to the problems that we have, we are going to start from problem 2.1, where we want to derive equation 2.7. And if you go back to equation 2.7, where is equation 2.7? And actually equation 2.7 is just the conversion. It is the conversion from the of ppm to milligram per meter cube. So what we will try to do here, we are just going to see that equation, which is 2.7, as you can see here. Okay, so that is the equation. And what we'll try to do, we'll just do the conversion. I think that is like very simple to do, but I think so sometimes it's good to just get comfortable about how did we get this equation. And all we are going to do is just going to substitute. And again, the problem, what does the problem say? Derive equation 2.7, that's all. So going to our problem here. So what do we have? So 2.1, what do we have? We want to convert milligram per meter cube to ppm. And what do we have exactly? And if we just look at it, is that if we have a certain meter cube species for amount of 1 meter cube total as a volume, and you try to convert that by multiplying how many grams you have within milligrams, and then how many moles do you have in that gram, that is through the molecular weight, and then how much through meter cube do you have per mole. And if you do all of these calculations, the numbers that you're going to obtain is you're going to have milligram per meter cube into 1 over 1,000 molecular weight, if I would say molecular weight, because we did not show the molecular weight, that is multiplied by meter cube per mole. Okay, beautiful. So if you talk now for an ideal gas, you talk about an ideal gas, 1 meter cube per mole is going to be equal to 22.4 liters per mole, and that is obtained at the standard STP. And if you multiply this by 1 meter cube per liter, and just for the ideal gas law, we are going to continue the PV is equal to nRT equation. So that is the continuation of the PV over is equal to nRT equation. And what you're going to obtain here, you're going to obtain the equation for meter cube per mole. Now if I want to look at what is parts per million, that's the ppm, this is equal to the meter cube of species into 10 to the power 6, and that is within how much? Within 1 meter cube total. And if you're going to calculate this, depending on that is the concentration that you are trying to achieve, this is going to be something like that, which is milligram per meter cube into 1 over 1,000 molecular weight into the standard 22.4 into 1 over 1,000 into T over 273, and that comes from the ideal gas law, multiplied by 10 to the power 6 Beautiful. So all what we have done is that we substituted here, and after that we have substituted, we are getting these equations here, and simply you're going to get your equation 22.4 over 273 into 2 into T over the pressure into the molecular weight, and that will be in milligram per meter cube. And if you do just the division, if you just do the division, you will have the ppm is equal to 0.0825 into temperature over pressure into the molecular weight, and that is in milligram per meter cube. So we are just showing that how we can do the conversion. And all what I want to say and all that is that it's not about deriving it. It is only for you to tell you that this is the conversion of ppm. Okay, sorry about that. This is the conversion of ppm to milligram per meter cube. Okay, so that's the whole story, right? Okay, that's the whole story. So that was not a big deal about this question, but this is how we had solved the first question. Now the real question that is related to toxicology, that the things that you're going to be really using. So 2.2. Okay, so let's go to the question of the second problem. And here, if you look at the question, and it has written that Finney reported the data of involving the toxicity of rotenone to the insect species. We want to see how toxic is that substance to the insect species. Okay, and that species is called that very difficult name, Macrosiphoniella samborni. Okay, the rotenone was applied in a medium of 0.5% of saponin containing 5% alcohol. The insects were examined and classified 1 day after spraying. Okay, so we are seeing that how many insects are affected because of that dose. Okay, the obtained data was as follows. So this tells you the dose of rotenone for the insects. So that's the rotenone. So with this dose, it was applied on 50 insects, and the number affected was 44. So if you want to see how much percentage was affected, is 44 divided by 50, which is about 88% were affected by that dose. If you inject that dose of 77.7 milligrams per liter on 49 insects, you find that only 42 were affected. And if you divide 42 by 49, it will tell you the amount of the affected percentage affected from the insects, and so on. If you go to 5.1, the dosage of 5.1, you will find out that there are 24 out of 46 affected, and so on. So all the story, what you're trying to say here, you're trying just to say that that is the question, and that the question is telling us plot the percentage of insects. We can see the percentage of insects here affected versus the natural logarithm of the dose. Okay, and you're going to get some kind of a curve. We're going to show you the curve, and then convert the data to Probit. Probit variable is good to calculate how many people are going to die. And sorry, here we're talking about insects. Okay, and then plot the Probit versus the natural logarithm of the dose. If the result is linear, determine a straight line that fits the data. Compare the Probit and number of insects affected predicted by a straight line fit to the actual data. Beautiful. So now we just want to see the percentage affected and then the Probit. So this is what you're going to do in our calculations, and then we're going to show you the figure. So going to our problem to be solved here. So what we have from data, let us see the data. And to fill in the data, so that is the dose. So we want to look at the dose of milligrams per liter, and we also want to look at the log of that dose, because we are going to use that log in the plot. And we already know how many insects do we have, and we also have the number affected from the insects. So the number affected. And from the number affected divided by the number of insects, we are going to get the percentage. and from percentage affected we can get the Probit. Beautiful. So, and that the Probit, actually, if you want to get it, you can go to if I can remember, it is table 2.4, table 2.4, and we are going to see that later together. Okay, so this is what we have. So the dosages that we had, the dose that we had, 10.2, 7.7, 5.1. So this is given by the question, 3.8, 2.60, and if we the parts of the question was given how many insects. This was applied to 50, 49, 46, 48, 50, and 49, and out of 50, 44 were affected, which was about 88%. So we calculated 88%. So, and I'll keep the calculations later, so I just put in a different color just to show you that that was calculated. So these are the numbers which were given. So this everything now is given. And now for the calculation, we are just dividing 44 divided by 50. So that is 44 divided by 50, okay? So this is what we are doing here. And we are getting 88%. And here we get 85.7 and 52.2%. And we have 33.3%, 12.0%. And definitely, if nothing is affected, okay, 0%, and if 0% is like 0 as well here for Probit. Okay, it could be 0 or negative, but that it just means like that. So I can just keep a dash for that. Okay, so and this is just the log, taking the log of 10.2, and because we may need that in just drawing the figure, it just gives us an idea of how things are getting affected. Okay, I'm just writing out those numbers. Okay, there's no log 0, so that's why it's a dash. So how do we get the Probit? How can we get the Probit? So if we have an 88%, okay, so that is 88. So if we have an 88%, how can we calculate the prob? So what you're going to do, you are going to go to the table, and the table here, if we just have a look at the table, and I'm going to go to the table that I have shown you in the presentation. You can also go and look at that in the book if requested. So where's the table? So here's the table. Okay, so looking at the table here, and just to zoom in, so what do we have? We had the numbers that we had was 88%, so going to 88%, and this is going to be like 80. Okay, I can see that's 80, and now it doesn't show, so that's 88%, right? So 88%, we can see the number here is 6.18. Okay, so what we are going to do, we're going to here write 6.18, and again, if you go to 85.7%, and that is we'll get something approximate here. So we go to 85.7%, so that's 80 again, 5.7. So something between 6.04 and 6.08, and I would say that 85.7 is like 85 point. It's closer to 86, right? So I would say that 6.07 is a good number. So I'll come here and say that this is 6.07, and so on. So this is what we are going to do, and we are going to get the list of the rest of the data. Okay, 4.57, 3.82. So that's the Probit. And remember, the Probit just giving something about the probability of the people who are going to getting affected. So now that we have obtained those values, if we just try to plot them, and of course I can't show you the details of how to plot this, but if you're going to plot this data, or we're going to plot the numbers that I have up there, and I'm going to plot what? I'm going to plot the percentage with the log of the dose. and this is what I have here. Okay, because it's log, it's going to be from 0 to 1, and the percentage, of course, is going to be from 0 till about 100%. Okay, and something it will be like 25, 50, and 75, and 100%. And you're going to realize that we are going to get something like that, something that looks like that, and those data that we do have here, okay, something like that, okay, and the data that we have here, I mean, I already plotted this before, so I have an idea, but if you can see here, the percentage, so it's like 88% at 1.01, right? So it's even less than that, so something like that. So talking about 1.01, for example, it was like 88%, so somewhere here, I think. So it's not exactly here, it's like here, 1.01, 88%. So it's all about the figure, right? The figure is not that accurate, and that is the reason. And you have another data here, another third data here. I'll just fix up this thing to be just more accurate, something like that. Okay, so this will be here, and another data here, and a third one here. Well, I cannot say exactly, but it's going to be something like that, and you need to do it and sort it by yourself. Okay, so you're just going to plot it. If we try to plot the Probit, which is y, okay, and Probit, when you say y, okay, if you have seen the equation for y, okay, so that is y is equal to k1 plus k2 ln v. V is the dose, or it is the causative. It's called the causative factor, right? It's the causative factor, and the causative factor, it could be different when we talk about, for example, emissions of certain gases or ppms. Here we are talking about certain causative. It's calculated as a summation of concentration multiplied by time, and this concentration could be 2 power 1 or 2 power 2, whatever. We are going to solve problems with that. So going back, we are calculating the Probit, okay? We are calculating the Probit. So, and what we have when we look at the Probit, if you look at the Probit and the log dose, I forgot to say that we are plotting it against the log dose. Okay, Probit against the log dose. So what do we have? We have at 1.01, we have 6.18, or we go the other way around, 0.415, 3.82, right? And then you're going to build your problem here, and you're going to have a figure that looks like something like that. Okay, something like that. Okay, and of course you're going to have data here scattered up and down, and this straight line is just done by an eye, just plotting it, and I think so you can do this by yourself, so I don't need to go into the details. But what I'm trying to mention here is that the equation for that was y is equal to k1 plus k2 ln v, the dose, right? The dose, or the causative effect. And here we're talking about the dose. And k1 is the intercept, right? So k1 is the intercept, and k2 is the slope. Okay, we already have the data of y and ln v, right? So what we are trying to do, first we're going to find the slope, and by the slope we can find k2, and if you do this, you're going to find out that the slope is equal to, you're going to find that the slope is equal to 1.2 divided by 0.3 is equal to 4.0. So you're going to find that it is 4, so we're going to find k2. Beautiful, so that is k2. And actually, to find k1, we already have a value for like y and v, the dose. So for example, there are many points that I can select here. So I can take the 5.06 with 0.708 or 6.07 with 0.886, and by these numbers that I do have, I can get the slope. So by just substituting the values that you have here, you're going to get a number, and by that you're going to find out that K1 which is the intercept, is equal to, if I just can have a look at it, K1, the intercept is equal to 2.2, and actually if you just draw this line and see what does intercept, you'll find out that it will intercept at 2.2. Okay, so like whatever you want to do through the figure or you do it through your calculation, it all works out. Okay, so what I'm trying to say here, this is what we have as the value of K1 and K2, and then you're going to have like your equation, which says that this is equal to 4 ln the natural logarithm of a certain dose plus 2.2. So that is our equation for the Probits. That is our equation for the Probits. So that was all about that question. It is like just a training of understanding how to calculate the Probit and how to identify the percentage of insects affected, how to draw this figure which shows the percentage of affected with the log dose, and how to draw the Probit against the log dose and get this slope where we can calculate K1 and K2. Of course, if we have K1 and K2, we can draw this figure. It's all going around and playing around with those numbers. Okay, so that was 2.2, and I hope that you also gained something of training yourself to understand what is Probit.